In 2025, a company called EarthGrid took a plasma torch system to the Sierra Granite Quarry in California. The torches reached 27,000 degrees Celsius and cut a channel through solid granite using spallation and vaporization. No drilling, no chiseling, no blasting. Just heat so extreme that the rock fractured and flaked away in fragments. When the channel was finished, the walls had slanted vertical patterns. Each stripe ended at the bottom with a curved corner. The channel opening was not perfectly straight, but slightly deviated. The top edges were rounded with smooth curvatures. In a smaller, two-torch tryout on a granite test block, the same system produced not channels, but shallow scoop-like indents. Depressions with defined outlines along the upper edge and soft, curved bases. The mechanism is dual. Some rock vaporizes outright at peak temperature. Surrounding material fractures through thermal spallation as the surface expands too rapidly for the crystal lattice to accommodate. EarthGrid's full systems are engineered to bore between 3 and 30 meters below the surface, producing the same signature on every cut. These marks are identical to the ones inside the trench surrounding the unfinished obelisk at Aswan, Egypt. A trench that is supposed to be 4,500 years old. Cut, according to mainstream archaeology, with copper tools and dolerite pounding stones. The unfinished obelisk lies in the ancient granite quarry at Aswan, still partially attached to the bedrock. At over 40 meters long and weighing an estimated 1,200 tons, it would have been the largest obelisk ever erected. The trenches cut around it are covered in distinctive marks, curved, uniform, approximately 40 by 40 centimeters each. The vertical cuts show the same dimensions. Whatever tool created these marks had a defined cutting face and was used systematically across the entire quarry. These are called scoop marks, and they are the most debated quarrying evidence in archaeology. The granite appears to have been removed in smooth, curved scoops, as though the stone yielded to the tool, but granite does not yield. It is one of the hardest building stones on Earth. Copper cannot cut it. Dolerite can pound it into dust, but pound marks look nothing like these smooth, curved depressions. The scoop marks show no sharp striations like those left by chisels or modern rotary cutters. No chemical discoloration or residue, which rules out the natron dissolution theory. The mainstream position has an experimental basis. Dennis Stocks of the University of Manchester demonstrated that dolerite pounders combined with sand abrasive can remove granite at roughly 5 millimeters per hour. His published experiments showed that the method works. It is slow, but with thousands of workers and years of time, it is feasible. The problem is not speed, it is shape. Pounding produces irregular, cratered surfaces. It does not produce smooth, uniform curves with consistent 40 by 40 centimeter dimensions repeated across an entire quarry. Stocks proved you can remove the material. He did not replicate the marks. No other experimental method has matched the shape either. Copper saws cannot bite granite. The metal is too soft. Bronze chisels chip the surface without forming depressions. Water jets tested for archaeological feasibility leave linear slots with sharp sidewalls. Rotary cutters produce circular cross-sections and deep striations. Industrial diamond wire leaves precise parallel grooves. Each of these methods has been tested, photographed, and compared. Every one produces a signature inconsistent with the Aswan marks. The 40 by 40 centimeter curved scoop is not a mark a mechanical tool leaves behind. The comparison between the Sierra Quarry and Aswan is specific. Both channels share the same width range. Both show slightly deviated walls rather than laser-straight cuts. Both have rounded top edges with curvatures. Both have slanted vertical striations ending in curved corners at the channel floor. Both were cut in natural granite. The EarthGrid plasma torches were invented in the last decade. If the Aswan marks were produced by the same method, then whoever quarried the unfinished obelisk possessed thermal cutting technology that we have only just reinvented. The comparison does not imply precision. The scoop mark tool was used for rough stage work. It separated blocks from their bedrock. It cleared trenches around the piece being quarried. Finer detailing, dressed faces, the pyramidion, hieroglyphic surfaces, required different tools still. This matters because it explains the appearance of the marks. They are not fine art. They are the signature of a first-stage cutting pass, preserved at Aswan because the obelisk was abandoned before any second-stage work began. The parallel holds in modern quarrying as well. Industrial stone operations use different machines for different phases. One for rough extraction, another for squaring and cleaning, a third for final surface work. The Aswan trenches represent the first phase of that sequence, frozen in place at the moment the workers walked away. And Aswan is not the only site. In 1983, Jean-Pierre Protzen of the University of California, Berkeley, documented cutting marks at the South Quarry of Cachicata in Peru. The quarry supplied stone for Ollantaytambo. Protzen, a rigorous academic who spent years studying Inca construction methods, wrote that the marks were very similar to those found on the unfinished obelisk at Aswan, and the technique involved must not have been very different from the one used by the Egyptians. Protzen's paper was a technical survey, not a speculative claim. He had spent the previous decade reconstructing Inca stoneworking by replicating it with period-plausible tools. When he wrote that the Cachicata marks matched Aswan, he was departing from his own prior reconstructions. The statement carried weight because it went against the simpler theory he had spent years refining. The quarry is granite. The marks match. And like Aswan, researchers found almost no tools at the site, only a few hammerstones of diorite and quartzite. The same absence of evidence, the same marks, on the same type of stone, on the opposite side of the planet. Two quarries, two continents, the same signature on the same material. That is the pattern that matters, because not every curved mark on an ancient wall is a scoop mark. Most are not, and conflating them has muddied this research for decades. At Sacsayhuaman, Cusco, Ollantaytambo, and Machu Picchu, shallow, curved marks appear on the surfaces of polygonal walls. They look superficially similar to the Aswan marks, but they are fundamentally different. They are on softer limestone, not granite. They are shallow and random, and they are not excavation marks. These marks are consistent with screeding, the process of dragging a straight edge across a soft material to flatten and smooth it. They appear alongside other signatures of cast construction: bulging blocks, airtight joints without mortar, and smooth surfaces with no tool marks. Joseph Davidovits, the French materials scientist who proposed geopolymer theory in 1979, has argued for decades that many megalithic structures were cast from an advanced concrete rather than quarried. A 2012 materials analysis conducted by a team of geophysicists concluded that the block material at Sacsayhuaman is not natural limestone, but a manufactured composite. Davidovits's team at the Geopolymer Institute in St. Quentin has published similar chemical analyses on samples from other Andean sites. The hypothesis predicts exactly what the Peruvian walls exhibit: airtight joints, smooth, non-exposed surfaces, and shallow surface marks characteristic of working a plastic material rather than cutting a solid one. At Machu Picchu, the evidence is telling. The non-exposed sides of wall blocks, the surfaces hidden by adjacent stones, are as smooth as the facing sides. No mason working at this scale, across thousands of blocks, would finish every hidden surface to the same standard as the visible ones. But cast blocks are smooth on every side by default. The Peruvian surface marks are not scoop marks. They are screeding marks on cast stone, a different construction method entirely. The physical process the cast stone hypothesis describes is specific. Larger blocks are poured in place against neighboring stones, while those neighbors remain rigid. Smaller blocks are cast in wooden molds and placed on the wall in a semi-cured state, still firm enough to hold shape, still pliable enough to yield under pressure. Once seated, the block is compressed from above and against its neighbors. Material squeezes outward at the seams before curing. Those bulges, visible on Machu Picchu's walls as thin, flexible ridges between blocks, are the signature of the process. Natural stone blocks chipped to fit each other do not produce ridges. Cast blocks compressed together do. Stonehenge Stone 59A presents a third misidentification. Certain photographs of the stone's surface show curved depressions superficially reminiscent of Aswan, but the marks appear on one face of one stone out of the hundreds at Stonehenge. They are not systematic. They do not share the uniform 40-centimeter dimensions. From alternative angles, the depressions look coarser and less defined, consistent with dressing marks on Sarsen sandstone that have been softened by 4,500 years of weathering. They are not the same phenomenon. At Yangshan Quarry in China, marks inside a rectangular cutout have been called scoop marks, but detailed footage shows sharp tool marks consistent with chisels or pickaxes. The surfaces are crude, without the smooth, continuous curvature of the Aswan marks. In clear footage, they do not match. So strip away the misidentifications. Remove the cast stone screeding marks in Peru. Remove the weathered dressing marks on Stonehenge Stone 59A. Remove the chisel marks in China. What remains is the genuine article. Uniform, smooth, thermally consistent excavation marks on granite. They appear at Aswan and at Cachicata, two quarries on opposite sides of the world, with almost no tools found at either site, producing marks that no experiment with dolerite or copper has ever replicated. A signature that, until 2025, no modern technology could reproduce either. A plasma torch system built by a Silicon Valley startup has now produced the closest match to marks that are supposed to be thousands of years old. The mainstream explanation remains copper tools and dolerite pounders. That explanation does not account for the curvature. It does not account for the uniformity. It does not account for the absence of mechanical striations. And it does not account for why a company needed 27,000-degree plasma to reproduce what ancient Egyptians allegedly achieved with rocks. Granite remembers everything done to it, and it remembers only one known process. If you want to support deeper research and found this journey as fascinating as we did, subscribe to Ancient Epochs for more.